Good day. This is the Equm math review. It's not much a review because for real details you can go back to specific videos on each topic. A, B, and C are all really linked together. For A, it means you have to be able to take an equilibrium chemical reaction and convert it to a K-equilibrium expression and understand what it's telling you about the ratio of products to reactants. For B and C, it involves questions where we're already at equilibrium. And so in the first case, it's really talking about if I give you the concentration of all the materials, you could work out the value of KQ. In case C, it means I give you all of the concentrations but one, and I give you a KQ, and you solve for the unknown concentration. But the key is, for B and C, you're already at equilibrium. For D, probably the hardest section we're looking at is this is the math where you are starting under some conditions, but you're moving to equilibrium. And as soon as that's the case, you have to use an ice chart. I for initial, those will be supplied typically in the question. C, the change, somehow you have to figure it out. Sometimes you can work out the actual numbers. Other times you're solving for X. And you have to remember stoichiometry in the C for change. E for equilibrium. Once you have the equilibrium concentrations, then you can go and finish off the question. You can give the unknown concentration, find a KQ, these kind of things. Sometimes for finding X, you can use the square root method if both sides are perfect squares. And unfortunately, if both sides are not perfect squares, then it goes to quadratic. And if you have a graphing calculator, that means you have to get into proper equation that equals 0 and solve for the zeros. E is very simple. It's a trial KQ. And from that, you're going to work out which way an equilibrium will shift or not shift. If trial KQ equals the actual KQ, well, then you're already at equilibrium. There's no shift. If the trial KQ is bigger than KQ, then it's going to shift left to reduce the amount of product and increase the amount of reactant. If the trial KQ is less than the actual KQ, then the reverse is true. It's got to shift right to increase the amount of product and use up some of the reactants. And then graphs, you will have to take information like from ice charts and be able to plot graphs. And that means you have to recall the different kind of stresses that we can have. And those include concentration stress, where one material's concentration spikes or drops before everything shifts. Pressure, where everything spikes or everything drops before the shift. And temperature shifts, where there is no spiking or dropping, it simply is a curve to a new equilibrium value. So again, not overly specific, but you do have the videos for all these other topics that you can go and revisit if you're having any kind of issues.